Ladies and gentlemen, let's start off with our very first panel today, helping to set the stage as to what Bitcoin layers are and can be today and in the future. Ladies and gentlemen, please big round of applause for our panel and their moderator, Elena from Hiro Systems.
Okay. Good morning, everyone. Yeah, I guess we'll just jump into it. Maybe we could start with intros, and then I'm excited to, break into what is a Bitcoin layer, given that it's been the only thing that we talked about yesterday was all about layers. So today we're going to define it. My name is Elena. I am product marketing manager at Hiro Systems. We're a developer tooling company, and we're building tools for Bitcoin layers like stacks, ordinals, and runes. And I've been a huge fan of the Bitcoin Layers project, and just following the space, trying to better understand how to think about Bitcoin layers and how to compare them. So I'm joined by my two esteemed panelists. Why don't we do a round of intros?
Yeah, sure. Hi, everyone. My name's Janusz. I work on a project called Bitcoin Layers, and founder of a company called LX Research. And we're essentially just trying to look at the landscape right now and tell people the trust assumptions that they take on when interacting with a lot of these new systems. So that's what we're doing, and excited to talk about some of the research we've been doing as well.
Awesome. Hi, everyone. My name is Andre. I am the head of product at the company called Bitcoin L2 Labs. We do core product research and development for the Stacks blockchain. Before this, I was actually at the Stacks Foundation leading product development for SBTC, which is a way to move Bitcoin into Bitcoin layers. So also spent a lot of time working with these two to understand what are the trade-offs of the different approaches that Bitcoin layers are taking, what are the ways that different layers are optimizing for that. And so, looking forward to today's conversation.
Yes. Thank you for introing yourself. So I'm smiling because we've been joking kind of like backstage that this is definitely like the semantic panel. If you want to go deep and debate like what's the right amount of trust assumptions at a sequencer layer, how should we be defining data availability? Like those are all the questions that happen in this like funny little rabbit hole of the internet that started a largely part with the Bitcoin Layers project. So I guess, how do you guys think about evaluating different Bitcoin layers? What's your favorite rubric?
So the way we're looking at it right now is like we tried to essentially, there's another kind of project that does this in Ethereum really well. I think the difference is like in Ethereum, you have a unified scaling roadmap. So every project is trying to design like in a similar way. So the trust assumptions and analyzing those is a bit easier. So we kind of were inspired by that, but took a different approach. We're basically looking at who's custodying the funds. So if you deposit your Bitcoin assets or Bitcoin into this L2 or layer-like system, who's custodying that? Do you have sovereignty over your funds, or is it another, party of signers? The second thing we're looking at is who is making the data available in the event that you need to validate a state transition. So if you're a rollup, who are the parties that are like receiving the transaction data from the sequencer and making that available in the event that someone, like, for example, needs to submit a fraud proof? Is it on-chain on Bitcoin? Is it a permissioned committee of people? Is it another consensus mechanism? The other things we're looking at, does the settlement assurance of the chain, like, is Bitcoin the ultimate finality mechanism? So is the transaction, like, if you're posting your state transition to, let's say, I don't know, Celestia, are you also additionally posting like a validity proof to some BitVM construction to finalize the state transition with regards to that specific bridge program so you can initiate withdrawals back to the Bitcoin main chain? That's another thing we're looking at. And then the last thing we're looking at is the liveness of the system. Like how many miners or validators are participating in the system? If they go down and if there's a liveness failure, can you bypass that and sequence your own transactions by submitting a Bitcoin L1 transaction? So this is kind of how we're looking at the initial kind of analysis of like a really quick snapshot of the trust assumptions. And then we go into a little bit more things of like, is it actually inheriting security from Bitcoin? Does it introduce things like MEV to the base layer of Bitcoin and like maybe additional centralization pressures? So we're kind of looking at these things.
Yeah. Andre, before we get to you, just to unpack, you covered a lot of ground there. So just
Yes,
to unpack that a little bit, like one of the things that helped me a lot in thinking about how to compare apples to oranges to layers to optimiums to thingamabobs and all these scaling solutions is that it's kind of a two-sided coin. On the one hand, you're looking for a layer that can extend Bitcoin in some meaningful way, either extend the functionality through fully expressive smart contracts or extend the scalability of Bitcoin, the L1, which is pretty limited. And then on the other hand, on the other side of that coin, you're trying to minimize the additional risks and trust assumptions that you're introducing into the system. And so the Bitcoin layers framework that you just described, like so much of it is like centered around those risk assumptions because you want to, I think the goal of the project, what it's done quite well, is say like, as an industry or as a team of builders, how can we agree to keep people informed and safe so that they can make educated decisions? And a big way of doing that is talking about risk in a standardized way so that people aren't kind of like flying blind. Andre, how do you think about comparing layers?
Yeah, I think that both of those are well said. The thing that I was going to add on to Janusz here, I think that's a really great way to look at the technical approach, technical framework for evaluating Bitcoin layers. But what I would add to that also is even more from a growth perspective, right? So what are the use cases that a Bitcoin layer is trying to optimize for, and how are they going to achieve that? What is the developer community like? Is it growing? Are developers engaged? Does the Bitcoin layer does it have deep Bitcoin liquidity? I think looking at liquidity for a Bitcoin layer is another important metric that users look at to be able to move in and out of positions really easily. So and I think that really refers to the first category that you mentioned, Elena, around really like how does the Bitcoin layer extend the scale and functionality? What does the user experience look like? And then you want to look at all of the additional trust assumptions as Janusz laid out.
Yeah, I mean, so we also did, like, I think it's a trope at this point where we're like, it's all about trade-offs. Like you can't, there's a trilemma and you can't be in the middle. You have to like decide, you have to pick a side. So a lot of the growth, like additional functionality, additional scalability, it's hard to do that without adding additional trust assumptions. And then a lot of the security properties or a lot of the like minimizing risk, that then limits like, okay, well, we're going to take a hit on scalability or we're going to take a hit on additional functionality. So if folks are kind of newer to the Bitcoin layers conversation, or if this isn't, a way that you think about layers, when I first started reading about this, I was very confused and I couldn't figure out like how to compare these things because they're also fundamentally pretty different architectures. So not only are you trying to compare like this two-sided coin, but there's basically a few different approaches that people are trying to take. And the way I think about them, this isn't like a comprehensive list, but there's like three main buckets. So you have like the ones that are on my radar. You have a bunch of Bitcoin layers who fit into like a sidechain category. That would be something like Stacks. It's a project that I'm involved in. Hiro like often creates tools for the Stacks ecosystem. Then you have on the other side of the spectrum state channels like Lightning, and Lightning is like such a beloved project. It's like kind of the known as the like only pure true L2, and it has its limitations. So a state channel is like the most minimized trust assumptions you could introduce. It does give you a lot of additional scalability limits, but it doesn't have that fully expressive smart contract like thing that a bunch of people are trying to build with. And then rollups, like the verdict is still out on a lot of them. It's an exciting technology, but they're still in development, but they're probably going to fall somewhere in between that spectrum. So with all that context setting, what do you guys look for in a Bitcoin layer? Like, what's the most important thing for somebody to look for in a Bitcoin layer?
I think the most important thing is, like, what are you trying to get out of the system? Like, what is your actual goal, right? Like, if you're trying to, like...
I'm trying to rebuild the financial system, duh.
It's like, so for example, like there's this thing called eCash, right? And there's this wallet called Cashew. And you can basically get some like Satoshis, and you can put it into these wallets, and you can put it into any number of custodians that are who are essentially acting as like these kind of like small little banks. And they have complete control of your money, but because of the way it's structured, they can't like center you individually. They can't rug you individually. They basically have to like shut down the whole bank and just like rug everyone in the system, right? So that like sounds like a very kind of like, why would I want to put my money into a completely centralized thing? But the reason you might want to do that is because there's a lot of different trade-offs. You can do things like offline payments. You can, the user experience is a little bit better sometimes. Sometimes people don't want to take on the not responsibility, but just like they don't want to have to go through the process of like running their own Lightning node and managing their own channels, et cetera, right? So like this is a really interesting system where in these like wallet applications, you can distribute your counterparty risk off like across any number of custodians, right? So if you're looking to put like $10 or $15 worth of Bitcoin into a wallet to like buy your coffee for the week, this might be a very reasonable trade-off that you're willing to make. I think a lot of people would push back on that and say like that defeats the entire purpose of these systems, and that is very valid. And if you want to make, if you want to have complete sovereignty over your money, then maybe different systems like Validity rollups, potentially when they come into market, or systems like Lightning, specifically for payments, is something that you want to use. So I think it just means like, what are you trying to get out of the system? And if you want to like kind of play all the degeneracy games that like a lot of people in other ecosystems love, then yeah, go for it. Eat your money into these like 3 of 5 multi-sigs that are run by these companies and play the casino. Like that's totally cool. But like I think understanding what you're trying to get out of a system not only allows you to select the system that's best for you, but it also allows you as a community member to not put pressure, but like voice your opinion in saying like, hey, developer teams, like these are the type of roadmap things we should be considering if you're trying to build like a completely decentralized L2 type blockchain system that is for permissionless financial applications. Then you have to like as a community member really push on the teams to like accomplish those roadmap milestones that get you there, because that's a big goal and it's very difficult to build. And I think like if that's the end state for everybody, then kind of outlining that process and the various stages that you're in during that is like super important.
Yeah. What about you, Andre?
Yeah, so I also think that the bridge designs really are the most important aspects when you're evaluating Bitcoin L2s, because these are the operators that are essentially taking custody over the funds, or you're entrusting with your Bitcoin. So it's really important to understand, what are the different trade-offs that the bridge is making in their bridge designs. I think that's why Lightning is perceived as the darling of the Bitcoin community, because essentially you're putting your Bitcoin in a 202 multisig, and you always have the ability to essentially submit a transaction to reclaim that Bitcoin from the channel whenever you want to. And I think, at least from the Stacks perspective, that's why we spend a lot of time looking at our bridge designs, because ultimately that is how we are going to unlock that additional functionality of Bitcoin that you can't do on the L1. And so, really looking at how do we make sure that this bridge is going to be secure and resilient. So that's why we look at certain design implementations, like being able to post collateral against the BTC that's in the bridge, or what are the incentives that signers are able to earn when they are participating in this system? Are they economically incentivized to secure this bridge? And so ultimately, I think that the bridge design is what's going to enable all of this new functionality that we're trying to unlock in Bitcoin layers. So that's where I would recommend people start as part of this.
Yeah. Janusz, I like what you said about knowing the design is also a really great way for, as a user, to hold the project accountable. And that makes me think like kind of earlier on in the year, there was a lot of debate, and there still is, around like unilateral exit. Should it be like the definition of what a true L2 is? How should we talk about these things? And I think like we probably oscillate back and forth between like definitions don't matter, or like definitions are the most important thing. To me, definitions like are helpful, but really the reason I think they're helpful in these contexts is because your principles matter, and principles are very hard to measure. And by setting a set of definitions, like this is what we aspire to, or this is the level of experience you can expect as a user, these are some guarantees. That's how people can keep you accountable. Otherwise, it does get to be a little kind of like esoteric or a little abstract. It's hard to keep straight.
It's completely trade-offs, right? So like if you have a system, right, a roll-up, let's say you have a validity roll-up and there's a smart contract bridge on the L1 and that smart contract has a like upgrade delay. So if like the signers of like if the owner, like the multi-sig that governs that contract wants to like submit a malicious upgrade, you get like 7 days to exit, right? And let's say it's a single sequencer model and you're transacting and whatever, and then like you notice like there's this contract upgrade that you don't want to like continue to have your funds in the system, but like if the fees on the L1 are too high, then you can't exit the system. So then you have to look at like the upgrade mechanism and like who are the parties responsible for that? Is it like a centralized development organization, whatever? And then you can kind of look at like, okay, well, like single sequencer rollups are bad because one day the fees on the L1 might be too high, so I won't be able to unilaterally exit. But then you introduce a decentralized sequencer. So let's say you use something like Comet BFT, which is like a blockchain design, and you have 2-second block times. Well, that's not as fast as the 350 millisecond block times you get from your big centralized box that's sitting in some data warehouse somewhere. So like, it's a trade-off. Now you're introducing better liveness protections, but now you're, falling back to like you have a worse user experience. So like for some applications, like let's say like on Arbitrum, they have like gaming applications. It's going to be very difficult for a decentralized sequencer to provide the amount of throughput and fast enough block times to ensure that those applications can continue to run in the way that they're running today with a centralized sequencer. So like it just depends on your application. Like it depends on like the use case, it depends on what you're trying to get out of the system, like I mentioned earlier, but it's just trade-offs all the way down. Like if you build like the most beautifully decentralized like roll-up style blockchain with unilateral exit and all these mechanisms in place, you're just not going to have the same user experience as one that's like just running a centralized box somewhere. So like I feel like when we talk about these things, it's just like, what do you want?
What do you want?
What do you want?
What do you want
from it?
Yeah.
What do you want from me?
I think it's also worth calling out that specifically for the Bitcoin ecosystem, the type of rollup that you're describing here,
Very
validity
different.
rollup,
This is very different.
It's not even possible today, right? Because Bitcoin doesn't have the ability to verify the data that is posted on the L2 because it doesn't have smart contracts on the L1. And so that's why like a lot of Bitcoin layers are trying to explore different trade-offs for what are the ways that we can get as close to this functionality as possible given the set of constraints that we have today.
I would say if you like want to learn how a like validity rollup might work in Bitcoin, like with the current like limitations, there's a podcast called Zero Knowledge FM. Go listen to that podcast with Liam Egan and Sims from Alpin Labs, and they kind of outline like the different parties and what's responsible for each like aspect of the transaction lifecycle. It's very different from how it works in Ethereum. So I think that's also why like we personally have had a lot of trouble like figuring out, like I don't know what to call it. It's a sovereign rollup. It's a sovereign ZK rollup with an optimistic validating bridge in the context of like the L2 native assets is a ZK rollup because the L2 is coming to finality based on like the validity proof that's ultimately accepted into the L1. But it's an optimistic rollup in the sense of like you're using only the Bitcoin assets because you care about the trust assumptions related solely to the bridge. So when you get into like the really like, I'm sorry, I'm ranting. But if you get into the definitions, it's all social consensus.
Yeah.
Like, it's all what people, like if I use a L2 blockchain and I only care about X token that's being used on the L2, then I don't care about the relationship that it has with the validating bridge with Bitcoin assets. Because if that bridge like went kaput and was completely shut offline, then the blockchain, like rollups would still work. The blockchain would still continue to make progress. It would continue to produce blocks. It would continue to post state transitions to Bitcoin. And it would just be a set of rollup nodes coming to consensus on the native assets versus the validating bridge, which may have like been hacked or stolen from or like forked off and created another rollup. So like it's completely as a user, like it's social consensus. Like when you look at all these systems that are being developed, it's not technically a Bitcoin rollup or a sovereign rollup, like a Bitcoin like BitVM rollup or a sovereign rollup. It depends like what you as the user are using with the system and like your perspective of it. So that's it's all social consensus.
Yes. But I mean, so okay, it's like 10 in the morning, second day on Friday of Bitcoin. Like I think we're like there is so much to unpack in what you just said, and no, do not apologize. Like I think these are like we don't have these conversations enough. Like it's kind of a bummer that these conversations happen in like 3 Telegram channel deep like rabbit holes of the internet. And this is like ultimately what we're trying to say, like do your own research, educate yourself. And the definitions are kind of like very hard to conceptualize. The models like that work in Ethereum don't always work in Bitcoin. So everything you just said, I think is valid. And if it confused any of you, like Google it. Like we need more people to be asking these questions, but I'll try to break it down a little bit. To summarize what Janusz was describing, like you just want to figure out how to talk about like what is the worst possible thing that can happen and how likely is that to happen. And so in these kind of like layer 2 or Bitcoin layer designs, there's two categories of bad things that you don't want to happen: security failures and liveness failures. Security failures is somebody screwing you over, and you don't want that. And liveness failures is the software not working as you wanted it to work. And so those are like, and these are incredibly complex cryptographic protocols that are really new. It's also like emerging technology. Zero knowledge proofs are something that like are just now kind of maturing, if you can even call it that, into like these applications that more than a few people can use. And so if you're trying to figure out like, all right, I'm trying to compare different Bitcoin layers, a place to start is, okay, what are the security failures and what are the liveness failures? Like what's the likelihood of those things happening? And that's where once you spend 6 months in a Telegram rabbit hole, you'll probably get to understand the different categories that Janusz was talking about.
And you just get really confused. I am like perpetually confused.
Yeah.
What do you like think about this, right? Like, do you think like what's like?
Yeah,
it's like a person designing this type of system.
Yeah, where my head initially goes with this is the three of us are very deep in the infrastructure of Bitcoin rollups and Bitcoin layers. But at the end of the day, how do you take this information and make it accessible for the end user?
Yeah.
How much does the end user actually need to know about the frameworks that you just described? Or is that up to the application developer to be able to articulate to the user what risks they are taking when they use like a more user-facing like application? So that I think that's the difficult part, because these are all, I think, really important topics for people to understand. What are the risks that they're taking? When you deposit Bitcoin into a protocol, what are the guarantees that you'll be able to withdraw that Bitcoin at the end of the day when you want it back from the L1? And I don't think we have a great way to describe that, because I would probably argue that users shouldn't know any of this stuff, and most users will not know at the end of the day.
Well, that gets into the problem of like, if the user doesn't know, right, and they put their money into this system and it all goes bad, right, then like hopefully then the system's designed in a way, if they don't know, then they could just leave. But then like, then you run into the problem if fees are too high on the L1, then that's when you get into the issue of like maybe what like, I don't know, maybe Stacks or Botanics are arguing is like, no, we need really, really like decentralized, robust, more like L2 infrastructure, because unilateral exit is going to be inaccessible for most people. I don't know if I would agree with that quite yet, but I think exploring kind of like, can we get to the path of like, you just use an L1 transaction to get out, or can we get to the path of like, the L2s are robust enough to where like if you have a liveness failure, right, of one sequencer or one block producer, then you can just rotate to the next one, right? So the chain doesn't completely halt. So yeah, and I think you can unilaterally exit L2 to L2. People are thinking about that in Ethereum, but I don't know a lot about the research. But yeah, that's another can of worms.
Yes.
Yeah.
Okay.
It's an important point, right? Like that is the end goal that at the end of the that I think a lot of people are aiming to work towards, is the ability to just submit an L1 transaction to be able to reclaim your funds at any time.
Yeah.
Right.
Yeah. Okay, so we've covered a lot of ground. One thing I'm really interested in is maybe we can take like, for the course of this year, as you've kind of dove deep into Bitcoin layers as a category, and as the category has itself grown and expanded, is there anything that you've changed your mind about? Like any hard opinions that you have kind of reevaluated, or like, any change of hearts that you want to share?
I think scaling blockchains with blockchains is not going to work out in the long term.
Hot take. Okay. And care to expand on why?
So like, and when I say that, I mean like decentralized, like blockchains, right? Like, there's always a limitation into the amount of throughput you can offer a user if you're running a distributed consensus network. And it's all about trade-offs. So let's say the bigger boxes you want to run, the more centralized the validator set becomes. And I think eventually, like if we have this like goal of the entire world transacting on chain, I think most end users will end up transacting on systems that are run by centralized boxes. And I think that is a realization I've come to. And I think just trying to like, in the modularity thesis, right, to centralize enough of the stack as much as you can and figure out like what applications need to be decentralized. A Zcash style, Monero style virtual machine or execution environment needs to be extremely decentralized because we don't want Uncle Sam going, that's bad, and we're going to shut down that box in that data warehouse somewhere. So we need that to be decentralized. But like if you're playing like a on-chain video game on Base, just let Coinbase run the box. It's totally cool.
Yeah.
So I think understanding where we need to decentralize things, and not everything needs to be this like massive like L2 thing. That's my hot take. Scaling blockchains with blockchains is really hard.
Yeah. Like the core problem with blockchains is that they don't scale.
Yes.
So it's kind of a funny thing then but I mean, I'm curious, Andre, if you have a different perspective.
Yeah, I was thinking about this too. For me, I think, and I'm not sure if this will be controversial here or not, but I think that Bitcoin actually should ossify. Now, which I didn't believe this even a couple of years ago, but as the space has developed, I now look at Bitcoin as this, $1.3 trillion asset class. We are rebuilding money and the financial system on top of it. And I think it's very important that it remains maximally decentralized and censorship resistant at the base layer. And for me, given where we are now, I think that the risk or even the chance of an upgrade introducing some sort of new vulnerability or unintended consequence into Bitcoin is probably a risk that isn't worth taking at this point. And so Bitcoin should ossify, and it does reinforce why Bitcoin layers are important, but it changes what the design space is that we're going to operate in.
So the great like script restoration project that's going to put in all the new opcode or all the old opcodes and restore them. That you would count that as like, we got to keep it ossified. So no more cats.
And again, like this is a new perspective.
Okay.
Because I don't think that this experimentation should be happening on the Bitcoin L1. Bitcoin is too important and too valuable to be doing that.
Say it. Say it's on the tip of your tongue.
We should try to make sure that we have before we go completely into this like layered modular scaling approach, we need to really ensure that we have better bridging protocols in place. I think if you look at things like Tornado Cash or the Samurai Wallet stuff, developers are being thrown in jail, and if you don't have a sufficiently decentralized mechanism to custody funds, you're a money transmitter. I'm sorry, if you're running a 3 to 5 multisig and that is your mechanism to secure funds on an L2 system, you, by the definition of the law that's coming, are a money transmitter. So you need to make sure that we have the opportunity to construct these systems in a way that gives we have the out of L1 inheriting full L1 security, because I would rather, I heard this yesterday in a panel, I would rather die on the hill that we make some risky decisions and it goes wrong, but we're trying to build systems that improve self-custody, privacy, and all of these things, than revert to a state where we're trusting larger, more trusted federated systems. Because in the end, I think that can turn in, that's a really easy target to bring these things down. So that would be my perspective on that. But yeah, I think it's a tough one.
And I think we agree on there's a lot of overlap in where we agree there, right? I think that the requirement that users can always self-custody their funds is essential to self-sovereignty. That is a core value of this space. The right to privacy and the ability to have confidential transactions, I think, is another key part of that. The question is how does it get implemented, right? There are different approaches that you can take with this. And so what sort of constraints do you have? And I think that's where the implementation details really matter.
Yeah, so like, I guess like my final thing is like, look at these systems and how we can build them and how can we ensure that they maximally inherit that like L1 security, and just allow users that opportunity to retain self-custody of their funds if that's something they want to do. And then, yeah, I think that's like the biggest thing, ensuring that happens.
Nice. Guys, that's all the time we have. This was an amazing panel. Thank you so much for sharing your time, your pearls of wisdom, and your hot takes. Yeah, I think that's all the time we have today.
Cool. Thanks, everyone.
Thanks, everyone.